Back to welcome back. Welcome to the next page of the notes, and we're going to go ahead and do example 2. We're going to find the extreme values of f on the region described by the inequality. So, because this is a region described by the inequality, instead of just we have a constraint, and the constraint is x squared plus y squared is less than or equal to 16. But because that also gives us a region, we're going to have to do one added part, and that is to actually find a critical point, because instead of just being on the line x squared plus y squared, we can be in that region. And so we could have a critical point somewhere in that region that's not covered by, what our level curve would be at x squared plus y squared equals 16. So the first thing we're going to do is we're going to go ahead and take the gradient of f. So the gradient of f is just going to be 4x minus 4, and then the y value, partial of y, is going to be 6y. And now what I can do is, again, in order to find the critical point, we would set the partial derivatives of x and y to equal to 0. So I'm just going to set my gradient of f equal to 0, or equal to the vector 0, and that's going to help me find my critical points. So if I do this, I can find my critical points. So 4x minus 4 equals 0 is just going to give me a critical point at x equals 1. So critical point is going to be at x equals 1. And then 6y equals 0 is just going to be 0 for y. So I have a critical point at 1, 0. And so I'm going to use this, and I can go ahead and say it. So I'm going to use this to find what f of 1, 0 is. So f of 1, 0 is going to equal to negative 7. So that's going to be a critical point. That could be a max, that could be a min. We're going to just hold that off and keep that up there on the right. So just to help us determine, okay, now using the level curve x squared plus y squared equals 16, is that going to be the actual max or min? All right, so we found the gradient f. Let's go ahead and we can redefine g of x to be g of xy to be x squared plus y squared. All right, that just gives us the surface. We don't need the actual level curve yet. That's equal to 16. And so when we take the gradient of gradient of g, we're going to get 2x for the x component, 2y for the y component. And again, we're setting up Lagrange, so it's going to be the gradient of f is equal to lambda gradient of g. So we want to find that Lagrange multiplier. All right, so let's go ahead and set each of these equal to one another. And because, again, we're going to match up the components, that's what we're going to do again. All right, so I'm going to have my component 4x minus 4 is equal to 2 lambda x. And then I'm going to use my other component and set that equal to it. And so I have 6y is equal to 2 lambda y. And so I'm going to look at this and try to determine which one is easier to work with so that we can find, our critical values. And so over here, I'm going to use 6y is equal to 2 lambda y. The reason I want to do that is because there's only two choices for this. Either y is going to equal 0, or lambda is going to equal 3. And hopefully you can see the algebra, because if y is 0, then 0 equals 0, that holds true. All right, and then also if I plug in lambda equals 3, then I'll have 6y equals 6y, or 6 equals 6, depending on if you want to get rid of the y's on both sides. So lambda equals 3, so I could solve it for lambda, divide both sides by 2y, and get 3. All right, so here are kind of our two cases. So if, in case, y equals 0, I'm going to go ahead and write that down here. So in case y equals 0, if y is equal to 0, all right, then what I can do is I can then use this to determine, then what's going to be my x and what's going to be my x value. And so to find this, I'm just going to go ahead and plug it into our constraint, x squared plus y squared equals 16. But y is 0, so it's just x squared equals 16. x equals plus or minus, oops, plus or minus 4. Square root of 16 is 4. All right, so here, so when y is 0, x is going to be, 4 and negative 4. So those are two critical points that we're going to have on our constraint. We can now also find our x using lambda. So if lambda equals 3, then I can go ahead and go over here to find what the x value would be. All right, and that would help me determine my y value. So if lambda equaled 3, then I have 4x minus 4 is equal to 2 times 3x, or 6x. Let me write that out so you don't get confused. 2 times lambda times x. All right, so I get 4x minus 4 is equal to 6x. Subtract both sides by 4x, I get 2x on the right side. Divide by 2, so negative 2. There's that spot where I can't write. Negative 2 is equal to x. So now, if x is negative 2, what we can do now is plug this into our constraint again. X squared plus y squared equals 16. And then now we have negative 2 squared plus y squared equals 16. Negative 2 squared. It's going to give us positive 4. Subtract that, so 16 is equal to 12. Square root both sides. Y is equal to the square root of 12, or plus or minus 2 square roots of 3. All right, so then that gives us two other points. When x is negative 2, when x is negative 2, y can be 2 square roots of 3, and, or when x is positive 2, negative 2, we can hit negative 2 radical 3. So we have 4 points that we also are going to have to check. So we're going to go ahead and plug these in. And we're done. All right, so I'm going to do f of 4, 0, f of negative 4, 0, f of negative 2, 2 radical 3, and f of negative 2, negative 2 radical 3. And again, now we're just going to plug these into our function f up here. All right, and to save some time, I went ahead and did that. So when we plug in f of 4, 0, we're just going to get 11. When we plug in f of negative 4, we're going to get 0. We're going to get 43. When we plug in negative 2, 2 radical 3, we're going to get 47. There's a spot where I can't write. And then the same thing, I'm going to get 47. So we have a max, and our max is going to be at f of negative 2 plus or minus 2 radical 3, because they both gave us 47. And then we're going to have a min, and that min is at not 11, but negative 7. So f of 1, 0. F of 1, 0, which is negative 7. All right, and that is everything.